Alright, so as you can see, this is part 2 of our right triangle trigonometry. And what we're going to look at is how do we use trigonometric identities to transform trigonometric equations. Now what you're going to need out is your identity sheet that you've been given. This will have all these different trig identities on there. These are things that you're going to need to know. Well, I won't make you memorize them, but you're going to need to know how to use them and where to find them on your sheet, because as you notice, there's a whole bunch of them. So sine of theta is 1 over cosecant. Cosine is 1 over secant. Tangent is 1 over cotangent. Makes sense from what we've been doing. Cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent. Tangent is sine over cosine, since it's y over x. Cotangent is cosine over sine, since it's x over y. And then we have our Pythagorean identities. These are going to be very important to you, because you've got to be able to see these in many different ways. Sine squared plus cosine squared equals 1. And you can rearrange these to be what you need it to be. 1 plus tangent squared theta is secant squared theta, and 1 plus cotangent squared is equal to cosecant squared theta. Now using these, what we're going to do is, it says we're given this part, we want to get this part to equal this based on those trig identities. So if you look at your sheets as I'm doing this, cosecant is the same as 1 over sine theta. Tangent of theta is sine of theta over cosine of theta. Just rewriting these. Now if you look, we can cancel this out with this, and that's going to give us 1 over cosine theta. And if you look at your sheet, 1 over cosine theta is secant theta. Just a matter of manipulating all of our different identities. Over here with this one, cotangent theta is, instead of sine over cosine, it's cosine over sine. We're going to leave sine theta here, because whenever we're doing these, 9 times out of 10, you're going to be trying to change them into sines and cosines before you try to change them into anything else. So this, we're going to cancel here, we're going to cancel here, and that just leaves us with the cosine of theta that we were trying to find. Over here, we've got addition, we've got 2 fractions, so what do we need? Yes, we got to have a common denominator. And if you look at this, the common denominator is going to be cosine theta, sine theta. That's our common denominator. Just like if this was 3 and 4, we'd put those together and get 12. So, if it's cosine theta and sine theta, that means I'm going to multiply the top and bottom of this one by sine theta. I'm going to multiply the top and bottom of this one by cosine theta. The bottom part's going to give me this. The top part's going to give me sine squared theta plus cosine squared theta. Now if you look at your identities, sine squared plus cosine squared is one of your Pythagorean ones, and that just gives you 1. So I've got 1 over cosine theta sine theta. And if we were to separate this, that would be 1 over cosine theta times 1 over sine theta. Well, 1 over cosine theta is cosine, or secant theta. And 1 over sine is cosecant theta, which is what we were trying to find. Yes, they can get pretty difficult. Yes, but you've got to make sure you just kind of keep things together and changing things to sines and cosines. Alright, last one here. Cosecant, cotangent, cosecant, cotangent. This looks very familiar, just like any of our algebraic things. We're going to FOIL this. So if I FOIL it, and let's get rid of some of this for a second here. Group it. There we go. Alright, so multiplying here and here, we get cosecant squared theta Over here, we get plus, or actually minus there, because we got a negative. Cosecant theta, cotangent theta. We multiply here and here, we get cotangent, cosecant, and if we multiply here and here, we get negative cotangent squared theta. Now notice the middles are going to cancel out because they're opposites, so that's going to leave us with cosecant squared minus cotangent squared theta. If you look at your trig identities, and the Pythagorean ones in particular, you'll see that you've got 1 plus cotangent squared theta equals cosecant squared theta. This is one of your Pythagorean identities. We can rearrange that so that we get this. In other words, if we were to subtract cotangent squared from both sides, that would give us 1 minus, all right, 1 is equal to cosecant squared theta minus cotangent squared theta. So you notice that this and this looks the same. So that means we can replace this, or this here, with 1, which is what we were trying to find. Manipulating these things. All right, real world application. Out in the forest, surveyors got to figure out how tall trees are. They're not going to climb them and drop a tape down to figure it out. So what they're going to do is use these formulas to be able to do what they need to do. So if we got a surveyor that's standing 50 feet from the base of a tree, so we got a surveyor guy here, he's standing 50 feet away. The surveyor measures the angle of elevation, so his angle of elevation means he's going up here, so this angle here is 71.5 degrees. You want to be able to figure out how tall this tree is. So all you're going to do is use what we got. This is going to be, we're looking for x here. Oh, something else to see, there we go. So this is opposite over adjacent, which we know to be tangent. So we've got the tangent of 71.5 degrees is equal to x over 50. We'll multiply. X is going to be equal to 50 times the tangent of 71.5 degrees. So if you plug that into your calculator, you're going to get 149.4 feet. All right. Hopefully there's no questions. This is pretty easy. Take your time doing these, and we'll see you in the morning.